Out there, in the vast black ocean of the cosmos, something is tearing through space faster than anything we've ever seen. Not a spaceship, not a beam of light, a galaxy, a swirling, colossal storm of stars, gas, dark matter, and it's moving at an almost unimaginable speed. It's not just drifting, it's racing, as if being pulled by something huge, invisible, and ancient. For decades, astronomers looked at this region of the sky and thought it was quiet, empty. But now, they've seen the signs. This galaxy is behaving in ways that challenge everything we thought we knew about how the universe works. What could make something this massive accelerate like that? Is it being dragged by a hidden force? Could it crash into something else? Or worse, is it running from something we haven't yet discovered? In this video, we'll explore what detail makes this galaxy the fastest traveler in the known universe, whether it's obeying or breaking the laws of physics, how dark matter and cosmic flows might be involved, and what this all means for the future of our universe. The galaxy we're talking about is known as 3C 186. It's not something you can see with the naked eye. It lies roughly 8 billion light-years away in the direction of the constellation Lynx. But what it lacks in visibility, it makes up for in raw cosmic drama. 3C 186 is a quasar, a type of galaxy with a supermassive black hole at its core, devouring matter and blasting out jets of energy so powerful they can outshine an entire galaxy. Quasars are already extreme, but this one is doing something that has never been seen before. It appears to be moving, not drifting slowly through space but blasting away from its host galaxy at a speed of nearly 8 million kilometers per hour. That's over 2,000 kilometers per second, fast enough to travel from Earth to the Moon in under 3 minutes. This discovery didn't happen overnight. Scientists first spotted 3C 186 years ago, using data from the Hubble Space Telescope and the Chandra X-ray Observatory. It stood out because its quasar, the blazing, energetic core, was oddly offset from the rest of its galaxy. That's not normal. In most galaxies, the central black hole stays, well, centered, but in 3C 186, the black hole appears to have been kicked out, violently ejected from its own home. That kind of cosmic eviction is not just rare, it's almost unheard of. Researchers began to piece together what might have caused this bizarre behavior, and what they found suggested a collision so powerful, so ancient, it may have shaken the very structure of the universe. To understand what's happening with 3C 186, we have to dive into one of the most dramatic events in the universe: a black hole merger. Imagine two supermassive black holes, each millions, even billions of times the mass of our Sun, spiraling toward each other in a deadly cosmic dance. Over millions of years, they get closer, tighter, faster. Eventually, they collide in a violent burst of energy, releasing gravitational waves that ripple through the fabric of space-time itself. That's the kind of event scientists believe happened in 3C 186, but with one critical twist. The two black holes didn't just merge and settle into place. Something went wrong, or rather, something extraordinary happened. During the final moments of the merger, if the two black holes aren't perfectly matched in mass or if they're spinning in opposite directions, they can release gravitational waves unevenly. Think of it like a rocket with an off-center blast. The force pushes in one direction. The result? The newly formed black hole gets a massive kick, like a cosmic cannonball, and is launched out of its galaxy. That's what scientists believe. We're witnessing in 3C 186 a recoiling black hole, ejected at speeds that defy normal galactic motion. This explanation isn't just speculation. It's backed by real observations and tools. Hubble helped reveal the physical offset of the quasar from the center of the galaxy, while Chandra mapped the surrounding X-ray emissions. The Laser Interferometer, Gravitational Wave Observatory, LIGO, has already detected gravitational waves from smaller black hole mergers, But what we see in 3C 186 may be the first visual evidence of a supermassive black hole merger with enough force to create a recoil. It's as if we've caught a snapshot of a galaxy in the aftermath of a galactic-scale explosion, frozen in time with its core flying out into deep space. This kind of behavior isn't just rare. It's a key puzzle piece in understanding how galaxies grow, interact, and evolve over billions of years. And it raises a haunting question. How many other galaxies are hiding these high-speed secrets, just waiting to be discovered? Here's the truly mind-bending part. The epic collision that likely launched the black hole in 3C 186 out of its galaxy already happened, billions of years ago. Because the galaxy is around 8 billion light-years away, the light we're seeing now left the scene long before Earth even existed. We're looking at a fossilized flash of ancient violence, preserved in light and just now arriving at our telescopes. It's like watching a supernova replayed from a cosmic time capsule. So, while it feels current to us, the actual explosion and recoil happened eons ago. We're just witnessing it now for the first time. What's even more astonishing is that we might not be seeing the end of the story yet. The black hole could still be interacting with material as it hurtles through intergalactic space. Over time, if it collides with enough gas or dust, it could flare again, emitting X-rays, radio waves, or even visible light. In the far future, with the right instruments, we might catch this runaway black hole lighting up the dark, a rogue core blazing like a distant alien star. And if something like this happened closer to us, the light show would be unimaginable. A supermassive black hole being ejected from a nearby galaxy could shine brighter than anything else in the night sky, maybe even rival the full moon. It could cast eerie shadows, be visible during the day, and turn our sky into a window onto a violent, evolving universe. Imagine stepping outside one calm evening, looking up and seeing a new light in the sky, one that wasn't there the night before. At first, it looks like a strange star, but it grows brighter by the hour. Soon, it outshines every planet, every constellation. Within days, it rivals the full moon in brilliance, casting shadows on the ground at night and glowing faintly even during daylight. That's the kind of spectacle we'd witness if a supermassive black hole like the one in 3C 186 exploded with enough energy nearby, a cosmic flare that would mark the sky for weeks or even months. The light wouldn't come from the black hole itself. Black holes don't emit light. But as it tore through space, swallowing matter and superheating gas around it, it would trigger a luminous eruption of radiation and particles. We'd see X-ray bursts, gamma-ray flares, and brilliant arcs of light stretching across the sky. It would be a global event, visible from every continent, sparking a wave of wonder, confusion, and maybe even fear. For humanity, it would be a reminder of how alive the universe truly is, that we live in a cosmos where galaxies collide, stars are born and destroyed, and invisible monsters can suddenly blaze into view. It would be a once-in-a-civilization moment, a silent, awe-inspiring broadcast from the edge of reality itself. What makes events like the one unfolding in 3C 186 so important isn't just their spectacle. It's what they tell us about who we are and where we come from. When black holes collide or stars explode, they don't just light up the universe, they forge it. The immense pressures and temperatures in these cosmic cataclysms are powerful enough to create the heaviest elements in the universe: gold, platinum, uranium. These aren't formed in the hearts of ordinary stars. They're born in firestorms of unimaginable violence, then scattered across space, seeding future planets, moons, and life. In a very real sense, these rare explosions are part of the universe's grand recycling system. Material from dying stars is flung into the cosmos, where it drifts, cools, and clumps together to form new stars, new planets, and eventually new life. Every atom of iron in your blood, Every bit of calcium in your bones was forged inside. An ancient star that lived and died long before our sun was born. That's the deeper meaning behind a galaxy like 3C 186. It's not just a fast-moving mystery. It's a portal into the violent, beautiful process that built everything we know. And when we look at other giant stars like Antares or VY Canis Majoris, we see echoes of that same future. These colossal stars will one day collapse, explode, or merge, creating the elements of tomorrow. Each explosion is a message written in light and dust, a reminder that the universe is still creating, still evolving. And so are we. Despite how dramatic all this sounds, there's no danger to Earth from what's happening in 3C 186. At over 8 billion light-years away, this event is unfolding at a safe cosmic distance. Even if we're witnessing the aftershock of a black hole being ejected or a colossal explosion lighting up its surroundings, the radiation will never touch us. What we see is just the ancient light, a story in the sky with no physical threat to our planet. If something similar ever occurred closer to home, say within our galaxy, we'd still likely be safe, especially if the explosion wasn't pointed directly at us. In such cases, we might see incredible auroras dancing across unexpected skies or detect a brief increase in atmospheric ionization. These would be more beautiful than dangerous. Thanks to neutrino detectors, which can catch the earliest signals from deep space events before light even arrives, scientists would have a head start. These elusive particles travel faster than photons, through stellar debris, giving astronomers hours or even days of warning. That means the entire world would be on alert, watching, waiting, ready to witness the universe's next great act. We're witnessing the final breath of a giant, a farewell millions, maybe billions, of years in the making. The light from 3C 186 is more than just radiation. It's a message from a time when Earth was still dust and gas, when our sun had not yet formed, and the Milky Way was a younger galaxy. And yet, here it is, reaching our eyes across time and space, inviting us to understand something far bigger than ourselves. Moments like these remind us just how vast and patient the universe is. We live our lives in heartbeats and hours, but the cosmos moves in millennia. Galaxies spin, stars are born and die, black holes collide, all while we go about our day, unaware that a cosmic epic is unfolding above us. And that's the beauty of space. It humbles us, but it also connects us. It shows us that we're not just observers. We're part of this great story. The same atoms born in stellar fire now live in our bones. We are made of this universe. So keep looking up. Somewhere out there, another star is dimming. Another galaxy is in motion. Another cosmic mystery is waiting to be seen. The universe doesn't hide its wonders. It simply asks us to pay attention. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts. In the comments below, we'd love to hear what you think about the mysteries of our universe.